the market of the IoT, that is very important. When we talk about that IoT, what is the future scope over there? Now over here you can see the market in 2014 that was approximate 2 billion, and in the 2020 that was 8 billion. But now as we are going to forecast in the India, that is approx 12 billion in the India after 2022, because 5G is being launched in the India in different cities, and in 2020, at the end of the 2022, that 5G will be in all the cities. So that going to add on some value in the IoT domain. So that is about the market over there. When we talk about the markets over there, you can see in the different segment like home, transportation, body, healthcare, building, and the cities. So the business impact over there, when we talk about the impact of those areas, so if you are willing to work in the IoT domain or industrial revolution domain, so over there you can come out with these areas, and their scope also, their exponential growth also, like home, transportation, building, healthcare, cities. So over there you can see in the all the data in the dollar. So you can see how the exponentially growth is over there. So when we talk about some more application of the IoT, that you can find it in the manufacturing, smart building, energy, environment, agriculture, logistic, home automation, smart city. So these are the common application over there IoT is being get implemented. So when we talk about the value chain or Industry 4.0 implementation in the manufacturing unit, like in the automobile sector, whenever we are going to manufacture any car, over there you are going to find the supply chain system over there like this, a value chain. First of all, we are going to design that vehicle in the software. Like there are some designing software that is being used in the industry, like AutoCAD, SolidWorks, and after designing that particular complete vehicle model, that is being get simulated first, and after that batch production is being get started. I mean all the individual component is being get manufactured separately. So over there you can see best size of the window, and very important point is over here is that whatever component we are manufacturing in the batch size, over there you can see we are sending the data of that component to the cloud. Mean how much component we have manufactured over there, all the data is being get recorded on the cloud. Cloud mean we can access the data from any location, any remote locations. And if the data like if we are manufacturing in the batch size, and just suppose we have to manufacture that door opener over there, the handle door opener over there you can find it, window opener, so that you want to manufacture separately in the 3D printer. So directly from the remote location also you can give that command over there using IoT, because all the data is going on the cloud, and this one is also connected with the cloud. And now in these days that is so much popular. When we talk about RPT, that is rapid prototyping manufacturing, so that is 3D printing. So that is also so much popular in the manufacturing domain also. Like till now in the majority of the country we are working on the plastic printer or polymer type of printer we are using it. But now in this day, that metal printer is also so much popular. In the metal printer, we can print realistic part that is being used in the different application. Like when we talk about aerospace application, one application that I'm just going to emphasize over here, like just we are going to purchase any defense equipment from any other countries, but sometime they are not going to transfer the technology over there. So when we have to do reverse engineering of that particular weapon or any equipment or any aerospace related equipment or fighter jet engine part or something like that. So for that we are using that metal 3D printer. So there are a complete set of steps that we have to follow. First of all, we are going to use a scanning process, mean that component we want to manufacture, we are going to scan it. So there is a 3D scanning option is also available. There is separate unit for 3D scanning. And after scanning that component, what next we are going to do? We are going to import that file in the SolidWorks software or any designing software, and we are going to enhance all the like some part is being not get properly scanned, that is being get enhanced. And after that we are going to send that command of that particular design file to the 3D printer. So there is some file format that is being used over there, that is STL file format, that is known as stereolithography file format, that is supported by 3D printer, or directly that part we can manufacture in the 3D printer. So there are different material is being used in the 3D printer, most commonly like titanium and aluminum and many more alloy also we can use it over there in the 3D printer, and we can manufacture realistic part over there. But it take a lot of time also, cost also, because when we talk about that 3D printer cost in the metal format, that is very high, approximate that range start from 1 cr to up to 10 cr. So that is only few institution in the India those are having that 3D metal printer, and one of the premier institute, that is NITT at Chandigarh also. Over there you are going to see metal 3D printer. And then second one in the Chandigarh, that you are going to find it in the CSIO Chandigarh. So now in the 3D printer over there, if any complex part that we want to manufacture in the 3D printer, that we can print it from the remote location also, because all the control is being get done over here. So this one is a cloud based part, all these things that you can see about this, because all the data going over here, we are controlling it, and we are giving instructions over there. That is IoT enabled manufacturing, that we can call it over there. So now after that we are using robots over there for assembling of all the different parts. So in the robot also, that is being get controlled by uh, top floor over there you can say, and that is IoT enabled. So if there is any troubleshooting, that also we can resolve it over there easily. And then after that all the part we are manufacturing it, their data is going on the cloud, and realistic report we can get it in the format of data, that how much component we have assembled and what is the realistic status of that particular component that we are manufacturing, or particular car that we are manufacturing it. So with the help of that, forecasting and prediction can be done easily. That how much production we are doing in this year, or in the coming 5 year, what will be the status of our productions, and how we have to increase it or decrease it. These are the management terms that is being used, but that is possible only with the data. If we are having realistic data, because there is a lot of manipulation in the data now in these day in the industry. Like when we talk about any company report, so whenever the company is going to publish his report about the production and all the balance sheet and each and everything, so there is a lot of manipulation in the data. But using IoT, that manipulation can be obsoleted, and realistic value we are getting it, so that realistic and transparency can be enhanced over there. Then after that we are going to manufacture that complete part, from designing to manufacturing to up to the delivery to the customer. All the data is being get monitored over there. And after that, if there is any optimization, or if there is any fault occurred while driving over there, that also get connected with the manufacturing software and all that, so that further improvement also can be done over there. So when we talk about some industrial robotics over there, the IoT is being get also used over there, and that is so much popular now in these days. When we talk about food processing industry, so in the food processing industry over there, maximum industry you are going to find fully smart and digital. And when we talk about digital, it means that is IoT enabled industry. So in the IoT enabled industry, so there is a no manpower engaged directly. The robot is being going to do all the assembly, and then after that they are going to uh, do like that is being controlled by human being. Just monitoring is being done by the human being or operator over there. all these tasks is being get done by robot. You can see over there some monitoring is being get done by some manpower, but all the process is being carried out using robot. In the same way, over there you can see in the welding technology or in the painting, paint shop. So some risky job over there also, like if the human engagement is over there, so that is very risky. In the same way, some component we are manufacturing, that is also very risky for the human being, like when we are going to manufacture blades. So over there during the manufacturing there are very fine particle of the blade or metal that is very harmful for the body when we are going to inhale intentionally or unintentionally. So that is very dangerous for the health. So that process is being carried out using fully automation over there. Now in this day that automation is being get integrated in the assembly line of the automobiles, and chip manufacturing, chip assembly over there, and the cutting process over there in the industry, like water jet cutting or many more cutting operation is being carried out over there. So you can see this example. This one is the industrial scenario. When we talk about fourth industrial revolution over there, you can see how much fast automation is going on over there. You can see in 1 minute, one product is manufacturing. You can see over there cycle time. Manufacturing means that is being get fully assembled and coming out over there. So over there you can see product is 232. After completing 1 minute, one product will be get add on over there, and the data is monitored remotely also. When if any vendor or any supplier or any sell store they want to get to know that how much manufacturing unit, how much production capability of that particular plant is visible remotely, so that you can see it over here. And very important point is that how many manpower is working over there. Very limited manpower you are going to find it over there, like 4 to 5% over there. One person is over here, one is over here, and three or more manpower you are going to find it over there. So one is going over here like this. So just visualize earlier in the similar kind of Maruti plant, more than 30,000 employees were working, but similar kind of plant is being get established by Maruti. One is in the Gurugram, Dharu Heda over there, and one more plant is being get established by the Suzuki in the Gujarat. So over there, they made fully automatic over there. Only 1 to 2,000 employees are working over there. They are just monitoring the process. If there is any kind of health in the production line, they are just going to troubleshoot it. So in coming days, you are going to find some smart robot also in our day-to-day life application. Also in some countries over there in the housekeeping services is being carried out using robot in some hotel or in their restaurant. So in India also in Karnataka there is one restaurant with the name of robot, and all the servicing is being done by a robot. So these are the trending things over there in coming days, and all the cooking thing also is being get done by the robot in China or some other countries over there. So as we are going to enter into 5G, so the application of that IoT is being get enhanced over there. Just see some pictures over here, like your cloth will speak out that when they have to wash it, and the cars will communicate with each other to avoid any kind of road accident, and many more add-on you are going to find it over there in the 5G integrations. 5G is just not about the internet speed that we are getting it in the mobile phone for accessing or surfing internet in the mobile for the YouTube and videos and like that, but that is more far away from that, for connecting things with each other, for industrialization of the things, for making machines smart, digital, and flexible over there. So over there you can see in the 3G there were limited connectivity, and as we have entered in the 4G, there were some more connectivity over there you can see. But as we have entered in the 5G, so there is more connectivity over there you can see. So as we are going to enhance the connectivity over there, so more the scope of job opportunity over there, that is being also get enhanced. So there are some disadvantages also. Whenever we are going to use IoT or smart manufacturing and digital manufacturing, there are some disadvantages also. So over there you can see some machine is being a design for serving the human being, but sometimes if there is any failure in the machine, so that can be very harmful and dangerous also for the manpower. Like just suppose recently 2 to 3 days back, one plane crash took place in the Nepal, and many casualty took place over there. So that machine is designed for man, but that can be dangerous for the man also sometime if there is any accident took place over there. So how we can tackle those kind of situation over there? So there is a new term that is being get introduced, uh, that is Industry 5.0. So that is the advancement of Industry 4.0. So what is that in the Industry 5.0? In the Industry 5.0 is that whatever IoT, smart factory, smart manufacturing we are using it, over there we are going to integrate that machine with the human being. So human being integration with the machine, so that we can avoid any kind of incident or any kind of accident over there. So that should be easily integrated with the human being. So that is the main focus of Industry 5.0. So in coming days, you are going to find machines will communicate with each other and also communicate with the human being, and they are understanding human behavior and each and everything. So based on that, those machines will be operated. And then after that, one more term is being also get introduced, that is Industry 6.0. Over there, AI is being also integrated in the machine to make intelligent machine. So that is far far away in term of industrial revolution, that will take more than 20 years in the country to come in the existence. But right now we are living in the era of fourth industrial revolution. So we have to be prepared about the future forecast also, because in coming days, what technology is coming, what skill set is coming based on that technology, because we have to prepare youth towards the new technology what is coming in the coming days. Because right now if we are teaching student in the first year, after 4 year a new technology will come out. So if we are not able to prepare that student in the coming technology, so the student will face a lot of challenge over there. So we have to be proactive so that we can inculcate those kind of skill set that is future trending. So in coming days, you are going to find robot for home application also. All the home task is being get done by robot. Yes, you can design some your own customized application also. That is just for entertainment. Yes, these are the few animations over there. You can see when the student is not having awareness about the latest technology and how boss is behaving in the industry. So just see if the student is working in the aeroplane and he is not aware about the latest technology in aeroplane. If there is any fault occurred, what can be happened over there? A plane can be get crashed. So that leads to a very big loss for that aeroplane company. Sometimes that those company can be shut down also. Their operation and all the planes can be shut it down. This few year back, one incident happened in Boeing plane. So they have downed all the planes in that particular model, and they have troubleshooted that problems. So that is very important, that whatever skill set is going on in the industry, that we have to inculcate in the students, so that they cannot face any kind of difficulty in the industry also when they are going to enter over there. So like all the component, basic component can be used over there for understanding IoT, like resistance, capacitor, some electrical component, electronics component, mechanical component. After integrating all these components, we can build some IoT applications over there. Like just see when a simple capacitor that is being get used over there, if the capacitor is being used in a reverse polarity, so what can be happen, that capacitor can be blasted over there like this. So understanding of that capacitor is very important. If that capacitor is being get deployed in the aeroplane in the reverse polarity, what can be happen over there? The plane can be get crashed over there like this. And you have seen recently one example that I shared with you, one plane crashed in the Nepal. So, like all the resistance, capacitor, you can understand it in animated format. And if you don't know anything about it, then also you can understand about these things. So, I'm going to introduce you one software that is very user friendly. Any kids can also understand about the basic concept, and that can be implemented over there. So, that can be implemented easily over there in the industrial product also. So like you can see LED, and LED also you can understand positive, negative, and this one is a process over there in that manual process. So there is one more scope over there in the industry. Like if there is a manual process, manual machines, so sometime industry is not able to afford that costly machines, because when we talk about industry 4.0 in India, there is a big challenge is that those machines they are using it for implementation of industry 4.0, those are very very costly, and all machines are imported from different countries like China, Japan, European Union, and over there. So, what can be the alternate over there? Now, in this day in India, there is one process that is going on to make factories smart in existing system. So, there is a retrofit kit is being get used for making that particular machine smart. Just see this example. This one is a boiler, and this one is a traditional boiler that is being used in the industry, and the boiler temperature and pressure is being get controlled by manual operators. So if we are using that process manually operated, that is very risky. So a few year back, there were one incident that took place in the NTPC power plant when boiler got busted and many casualty took place over there, because that process were manually over there. Because sometimes there is a chance that if worker is working over there, they can go for sleep also. That can be chances if there is no boss is absent over there, and the one boss is present, the worker is working like this. If there is any risky operation over there, so we can make it smart to avoid any kind of incident or accident over there. So there is a retrofit system that is being so much popular now in these days. So this one process we can make it automatic using IoT, and we can monitor it remotely also. Like if the boiler is going, the pressure and temperature of that boiler is going above the threshold limit, so we are going to get notification in the mobile phone, and as well as in the mail also. Mean higher authority can be get notified, so that they can take any preventive measure over there to avoid any kind of accident over there. So yeah, that I said with you. So we can use different technology over there to understanding IoT. So there are microcontrollers can be used, microprocessor also can be used over there. Like these are the commonly open source platform that is being used for the learning application. Might be you familiar about it. So one is Arduino, and the second one is over here that you can see, that is a Raspberry Pi. So these are open source microcontroller and microprocessor that is being used for IoT applications. So we are trying to understand basic components over here, like Arduino, how it is working and how we can use it, and also Raspberry Pi also, that how it will work. So first of all, when we talk about Arduino based IoT application, or when we have to build some smart application using Arduino, so how we can build that one, so that we are going to discuss over here. So let's see how we can use that Arduino for IoT applications. So the tool that we are going to use it over here, that is also free tool that you can use it for designing your circuitry, and then after that testing it over there without having any kind of hardware, then you can go ahead with that particular tool. So what I'm going to do over here, I'm going to open this tool and going to introduce about this tool. The name of this tool is Tinkercad. So how many of participants are familiar about this Tinkercad? Kindly type in the chat box yes and no if you are familiar about it. Otherwise, I will let you know each detail of this tool, that how you can use this tool. So you can type in the chat box so that how many of participants are familiar about this tool, the Tinkercad. Is how many of participants are familiar about this tool. So you can type in the chat box yes and no. If you are familiar about it, you can type yes. Otherwise, you can type no in the chat box. Yeah, I'm waiting for your response. So type in the chat box either yes or no. Simply, that is very simple. It's not any complicated question over there that I'm posing you. Very simple. If you are familiar about this tool, that is Tinkercad, you can type yes. Otherwise, you can type no in the chat box. I have not received any response in the chat box. So this one is not a tough questions. So when we talk about Tinkercad, meanwhile I'm just continuing it and also waiting for your response in the chat box. So when we talk about this tool, how it will work, so I'm going to open this one. So just directly you have to go to the Google, and over there you have to search with the name of Tinkercad. So I'm just going to open the Chrome browser. Over there, I'm going to search Tinkercad. You can directly search over there Tinkercad. So as I'm going to open over there, it will look like this. So directly I open Tinkercad. Let me search it directly Tinkercad. On the Google, I'm searching it first. You are going to find it like this. So over there, what you have to do, you have to click on the Tinkercad like this. And then what next we have to do it over there, the web browser is being get open over there, and this one is the online tool, that is very important. So whenever we are going to use the Tinkercad, this one is a online tool that we have to use it over here. So first of all, over there what we have to do, we have to do sign up over there in the Tinkercad. So how you can do sign up over there, there is option of sign up at the right top corner that you can see it. So I'm going to click over there, sign up. So first of all, there is one option that is educator, then student, then last one option that is create a personal account. So that you have to click over there. So the third one option that we are going to click it, that is create a personal account. So as we are going to click over there, you are going to get these options: sign in with the Google, sign in with the Apple iPhone, or sign up with the email. So you can sign up directly with the email also. If you have already signed in your Chrome browser with your Gmail account, so directly you can click over there, sign in with Google. So as I'm going to click over there, sign in with Google. So we are going to open it over here. So it will ask permission about your Gmail account, and after giving permission, you are able to log in over there in the Tinkercad. So directly I log in the Tinkercad with my Gmail account. So after doing login over there, you are going to find these options. You can create a classroom also for the remote learning. This one is a wonderful tool. So if you are teaching remotely, then also you can use this tool, and you are going to get these options over there, design and tutorial. So I'm going to click on the design part, left hand side, that is design. Over there, I'm going to click, that is design. So as we are going to click on the design, you are going to see this option, your design. There is a 3D design option and the circuit options. Whatever design you have done earlier, you are going to find it over there. If you are using it first time, you are not going to find any design over there. So for that, what you have to do, you have to go to that plus new option at the right top. At the right top, you are going to find plus new. So as we are going to click over there, you are going to find like this. So there is a two option. One is 3D design. Like if you want to work on the 3D printing, that also you can make your model easily. So I will let you know quickly about that 3D design. Then I will move towards the circuit part, that how you can make any kind of circuit for IoT applications or a basic smart project or automation project. So first one is a 3D design. Click over there. As we are going to click, you are going to find like this. So now as we are going to open that any kind of 3D model, so you are going to find this workspace. So all the pre-built blocks we are going to get it over there. Using this, what you can do 3D designing, and directly you can move for 3D printing also. So over there you can drag any component like this, and if any dimension you want to change, that you can change it like this. The dimension you can change it. After changing dimension, any modification you want to do it, like any hole you want to create it, you can take this one. And after that, what you can do, you can change dimension over there. So the dimension, I'm just changing it over here like this, and you can move it up and down. These are the different views, like front views, top view. So you can see it will look like this from the front. From the top it will look like this. And then you can club it. Club mean that whole you can create it by selecting complete part, and you can group it. So there is a grouping options. So as we are going to group it, you can see the whole is being get created over there. So that hole is being get created over there. You can move it like this, and you can check it out over there. And then what next you can do, you can do 3D printing of this part, whatever part you made it. So how you can do, there is option of export and send to. When we are going to click on the export, download and 3D print, so this file is being get downloaded in the .stl file that is compatible for 3D printing. So when we have to do 3D printing, so you can use that .stl file, and you can do 3D printing using that one. And then there is option of directly 3D printing. So you can click over there. There are some open source 3D printer. If you are having any 3D printer out of that, directly you can select that 3D printer, and that component is being get 3D printed over there. So that is about 3D printing over there. And if you want to advancement about this design, for that you can send to option is there, and you can send that file to any advanced software also. You can share it in the Google Classroom also, and you can take a screenshot also of that picture, so that you can add on in your documentations, and that can be done easily. So this one is about that 3D designing tools. Now coming back, so this one is a Tinkercad dashboard. Click over there. You will come back to the starting positions. So from over there, we are moving towards circuit. So let it get open, and after that we are moving towards circuit part. So I'm going to move ahead with circuit. So over there, same thing is being get open again, as we have logged in over there in the Tinkercad. So you are going to find plus new option over there. Click over there. After clicking, what next we have to do over there? We have to click on the circuit part like this. This one is the second one option. So earlier we have discussed about 3D design. Now we are talking about circuit part for making any kind of IoT applications. We are moving towards circuit part. So in the circuit part, what next we are going to do it over there? We are moving towards components. On the right hand side, you can see all the components over there. So plenty of components are available over there. Out of that, you can make any kind of circuit design. So I'm just going to start with a very basic design. You will also enjoy it. So I'm just taking LED, just drag it and drop it. So you can drop it. If that component is not visible over there, you can click over there, fit to screen, zoom to fit. So that component will be visible over there. Then you can connect this component with the battery. So very simple connection, we are doing it with the battery. So this one is a battery is not visible. You can click this zoom to fit, so that component size is being get reduced. So now this one is a 9-volt battery that is available in the market in the same pictorial format that you can see it over there. So now what next we are doing it over here, we are moving ahead over there. So now what we are going to do it over here, we are going to connect circuitry over there. So circuitry, we are going to connect it over there. So let's see how that circuitry is working. So I'm going to click it. This one is a negative that you can see. Negative, you have to connect it with cathode. And then after that, this one is anode that I'm going to connect it with battery positive. So that wiring you can do it. Again, I'm just going to let you know that how that wiring you can do it. You can try it with your own. That is very easily. You can do it. So I'm going to click over there. As we are going to click, wiring is being get started like this. So if you want to end this wiring, how we can do it? Either you can use escape button from your keyboard, or directly you can do undo also over there. So or you can connect it with any point over there that we can connect. So if you want to delete it again, select it and delete it using this one, or you can use delete button in your keypad. So again, I'm going to connect it, and if you want to make any twist over there, click it, and if you want to take 90-degree turn over there, again click over there like this. I connected it, then again anode like this. We have connected it, and you can do color coding also over there. Like this one is a positive, that is red. So you can click over there and you can change color also. So I'm going to make it red color over there. So for making it red, I'm going to click on the red, and you can change it in the black color, black. So this one is my basic circuit that is ready, and you can rename it also, that is LED test. So after doing this, what next we have to do? We have to start simulation, and we have to check it out that LED will work with this battery or not. So I'm going to start simulation. Simulation has been started, and now you can see LED get damaged over there. You can see LED is working, but that is being get damaged. So what we have to do over there, we have to check it out what is the fault. So you can take your mouse cursor over there on the LED, and you will see all the property of that LED. That current through the LED is, that is 915 milliampere, but the absolute maximum that is required, that is 20 milliampere. It means high current is flowing in the LED. So what we have to do, we have to reduce that current. The current we are going to reduce it. So how we can reduce that current? I'm going to add on resistance over there. So resistance is available, take it, and we are going to put it over there. So let me take it again. The resistance, we have taken it over there, and that resistance we are going to connect it. So any wire you can remove it and connect that resistance, and we can connect it like this. So that we have connected it over there. Then after that, what next we have to do? We have to start simulation. So the simulation we are going to start it. Now you can see LED is working fine over there. So that LED is working fine over there. So now what next we have to do? We can change that resistance value also. So I'm going to make it 220 ohm. Now there is some warning that a little bit more current we have to increase it. So I'm going to increase current over there, that is 300. Then also warning 330, that is also warning, make it 400. Then it is working fine. So that you can calculate using Ohm's law also. That is the theoretical behind that, that I'm not going to discuss. So now it is working fine over there. So now what next we have to do, we have saved this circuit and we are going to check it out that your circuit is saved or not. So for that, what we are going to do, I'm going back in the Tinkercad, click over there in the dashboard, and you will able to see whatever circuit you have designed, that is being get saved over there. So now this one is the latest circuit that you can see it, that is LED test, that is being get saved. That is very simple one. It's you can open it again also. There is two resistance we have added, we can remove this one and you can tinker this again, and you can share the circuit with in the Google Classroom also, so that student can access that circuit easily over there. So now this one we are going to extra component removing it. Now it is working fine. You can start simulation also and you can check it out. So that value we have not saved in increase mode, so let it stop and you can make it 320, then it will work. Make it 350, then it is working fine. So that is being get saved over there. So now again, whenever you have to start new circuit, how you can start new circuit? For starting new circuitry, what you have to do, you have to uh, click on that dashboard, Tinkercad dashboard, and start new circuitry, so that the previous circuit is being get saved over there. So now I'm going to move ahead and I'm going to click on plus new and circuit, and new circuit we are going to design it over there. Very simple project we are making it. These are very simple, anyone can do it. So now we are going to test it out any motor. So any motor you want to connect it, just take it, and then after that you can click over there in that particular button. Potentiometer you can take it, or battery you can take it, or you can take sensor also. I'm just going to take one sensor over there, that is LDR sensor, that is photo resistor sensor. So that is photo resistor sensor that we are going to take it. So now over there what I'm going to do it, I'm going to select one battery also. Any battery you can select it, multiple battery you can find it over there. So now I'm going to connect it over there like this. So what we have to do, we have to take wiring like this, and this one I'm going to connect it with this, and this one is with this. So that simple connection I just made it. So you can adjust the wiring schematic positioning over there using those points. And like this one I'm going to adjust it like this. Color coding also you can do it in the same way. Now as we are going to start simulation, you can see motor is running with the -6 rpm. -6 means that is in anti-clockwise direction, negative representing the direction over there. And you can click on the sensor. As we are going to click on the sensor, this one is a light dependent resistor, mean when we are going to for light intensity over there, what is happening, the resistance value is changing when we are going to fall light on this sensor. As I'm going to click over there, you can see this one is darkness, full darkness, and this one is a light intensity, that is the sun radiation that is being get simulated in the software. In the real time we have to get it light intensity from the sun or room light. So as we are going to increase light intensity, what is happening, motor rpm is increasing, motor speed is increasing, you can see, so that you can easily simulate it over there. In that way over there you can see, so that we are going to take it. So you can see it increasing light intensity, decreasing light intensity. If you want to change the RPM in the positive direction, so you can just change the connection over there. So that wiring, I'm going to do it reverse. So the positive directly I'm going to connect it with the positive, and this one I'm going to connect with the negative, so that we can change the, as we are changing the polarity, what is happening over there, we are changing the direction of the motor. You can see now it is positive 6 clockwise. As we are increasing light intensity, rpm is increasing or decreasing. And that project also you can save it, that is motor test. So you can click again back over there, and you can see your name is being get renamed. Click back. Now we are talking about the Arduino code, how you can program it easily, because maximum time we are afraid about the coding over there in the microcontroller. Whenever we are talking about the IoT, we are afraid that we cannot do coding, how we can do it. So that I'm just going to let you know that how easily you can do that coding. So that I'm going to tell you over there. For doing coding, what you have to do, you have to go to this new circuit that we are going to make it, and very easy graphical coding that we are going to do. Go to the circuit, and after that what next we have to do over there, we are going to click on the Arduino board. This one board we have to take it. So Arduino is a microcontroller development board that is easily available in the market also, and very cheap also. So any project you want to make it, that you can make it using Arduino. Also the basic project also for the student applications, and the advanced project also for industrial application also, similar kind of board you can use it over there also. Now over there, if you are not familiar about it, no need to worry, just follow all the steps and you will able to do the basic coding easily. So I'm just going to make code for LED blinking, LED on and off. So for that, I'm going to take one LED. LED we have taken it, and I'm going to connect this LED. One is a cathode, one is anode. Anode is a positive, cathode is a negative. Negative with a ground. GND is a ground, and the positive we are going to connect with 13 number pin. After that, what next we are going to do it? We are going to start simulation directly without writing any code. You can see we have started simulation, and after starting simulation, you can see LED start blinking. Some warning is over there because we have to connect resistance over there, but LED is working fine. Blinking is fine. But how that happen without writing code? So for that we are going in the coding, and by default you are going to see this code. This one is a graphical coding. We are not doing any C coding or any Python coding. Very simple graphical coding we are doing it. And when we are going the background of this graphical coding, from where that coding came, so there is one another software that is open source with the name of Scratch, that is being taught in a school also for understanding programming. So the name of the software is Scratch. The coding came from the Scratch software. Scratch. So that you can use it in online mode also, offline mode also. So the Scratch, you can open it. I'm going to click over there, Scratch, and it is being get opened over there. So you can start creating. So how you can use the Scratch software, that is very user friendly and very easy to use, and you can understand graphical coding easily, that how the coding is working over there. So you can see over there how it is being. You can make some animation over there easily using this software. So that animation you can make it using like this drag and drop. You have to do it. After drag and drop, you can move this panda or cat over there. Like these blocks, you have to drag and drop, and easily you can play any kind of animation over there. So now in that way you can delete component and all, any kind of animation kind of things you can make it over there using graphically. So that is about this uh, Scratch software. So over there, when we have to make any circuitry using that Scratch software, So how you can make it, that we are going to discuss. Like this panda, we want to move it. So for that, what we are going to do it, I'm going to move it 10 step. We want to take turn 15 degree again, move it 10 step. That step also you can change it, how much step you want to make it. I'm going to make it 100, 15 degree, or you can make it 90 degree. Then you can make it 100 step, or you can make it 50 step rather than 100. Let me make it 50 step. And then you want to play some sound, so over there these are the options like sound. So go to the sound, play meow sound until done. And then there is a event and control. In a control, you are going to see how many times you want to repeat it. So I want to repeat it 10 times. These are the loops over there, for loop, forever loop, or conditions you are going to find in a control. So I want to repeat it 10 times. Then there is an event. In an event, you are going to find this flag. Mean when we are going to click on this flag, then it will start simulating. So as I'm going to click over there, when I'm going to click on this flag, so my simulation is being get started. So this one is very fast as I'm going to click. So you can take some delay. So go to the control. There is a wait. So you can take wait over there for 1 second. And as we are going to click over there, the simulation is being started. I think you are not able to hear that cat sound, but that cat sound will be audible to you over there, that you can see it like when you are going to play it. So now in that way you can any circuitry over there easily. If you want to repeat it more than 10 times, now it will repeat for 10 times. You can see it is repeating, and it will play sound also, cat sound also over there. You can change that sound also over there. Let me check it out if the sound is working. So you can play it again. The sound system is not working over there, but you can try it with your own, and that sound will be audible to you all in that way. So now you can record customized sound also over there. There is many more feature you are going to find it over there in this tool. So that sound customization also you can do it over there as per your requirement. And you can change that panda also, many different kind of pandas, animals you can get it, people over there you can get it. So this one you want to take it, so you can get these options over there. And you can add on some background also over there. Like I'm going to add on that city background, that also you can add on. You can change it. So many options you are going to get it over there. This one is for the beginner, like for understanding graphical coding. Coming back to the circuitry or this tinkercad, in the tinkercad you can get only limited coding that is dedicated for this arduino program. So over there, this one is a simple by default code we have received for LED on and off. So if you want to make it this code again, how we can get it? I'm going to delete it. How we can delete it? There is a dustbin at the right bottom that you can see it. I'm going to drag it and put it in the dustbin. And again, we have to go to the control. In a control, we can get that forever loop. Drag it. Then we have to go to the output block. In output, there is second block, we have to take it, set pin, this one, and you can select pin number. So LED is connected on which pin? The LED positive is connected on 13 number pin. So these are the pin number we can select it. So if I'm going to change the pin number over there, like 11 number, so what we have to do? We have to select over there pin number that is 11. So the simple logic we have to make it, LED is high. High mean on 11 number pin LED is high. How much time? So for that go to the control and we have to take the delay. Wait. So LED will be high for 1 second, 2 second. The time you can set it. And after that, what you want to do it? LED we want to make it off, low. For that, we have to go to output and we have to take it again, that LED block, second block in the output. Second block we have taken it, and over there we have to select that block, the pin number that we are going to select it, that is again same pin number, that is 11 number pin. So that we have selected it, and then again we have to take that wait delay. So delay we can get it in a control, you can see with the color code also. Delay we can get it in a yellow color control. Wait. So LED will be high for 2 seconds, and again LED is high, we can make it low for 1 second. This one sequence will be repeat for infinite time. So you can start simulation and you will be able to see on the 11 number pin, LED will be high for 2 seconds and LED will be low for 1 second. And if you want to remove that warning, what you can do, you can add on one resistance with the LED so that any warning can be removed over there. And you can rotate this component also. Click on the component, there is a rotate options like this, and you can connect it with the 11 number pin like this. Now you will not get any kind of warning over there. So now you can see LED is working for 2 seconds on, 1 second off. In that sequence, it is working. So that is very simple code for LED on off. So now we are going to move ahead with some advancement, some advanced project if we are going to make it over there. So how we can make it over there. So this one we made it for LED for on and off, and this one is the code. And very important point is that from this code you can generate C++ code also. Click over there and you can click block plus text. Again repeating, stop simulation, click on the blocks plus text, and over there you are going to find this one is a C++ code that is automatically generated. As we are going to remove some of the component, your code is being get removed over there like this, that you can see it over there like this. So in that way you can write your code in a graphical way, and your C++ code will be generated easily over there. Now we are going to move ahead over here and we are making some more interesting project, like automatic door opening project you have to make it, or automatic doorbell you have to make it. How you can make it? So for that we are going to use sensor also, and we are going to use if else condition also in a very simple and easy way. So these are the basic for starting in direction of the IoT. So you can understand all these things using this graphical tool or online software without having any kind of hardware component. Because when we talk about IoT, for that you required a things. Things mean hardware, means sensors. So this one is a PIR sensor, that is proximity infrared sensor. So the sensor is working based on the infrared light, and when any object is coming in front of the sensor, it will detect that person, and automatically you can turn on and off any buzzer or any door opening or light on off, you can do it. So that we are going to discuss. So the sensor is working based on the two conditions. One condition is that there should be a living being in front of the sensor. Second thing is that that living being should be in a motion. If that living being in a stationary position, the sensor will not work. That you have to take care. So there is some delay system also in the sensor, that also we can calibrate in somehow, in some extent, that we can calibrate it. So how the sensor is working and how we can do circuit connections. So for that I'm going to connect it. So there is a 3 wire in a sensor. Commonly in all the maximum sensors we are going to find 3 wiring. So what we are going to do it over here, when we are going to connect the sensor with the Arduino. So first wire is the ground. So ground wire we have to connect with the Arduino ground. So this one is a ground. So multiple ground pin over there in the Arduino. 2 ground is over here. GND mean ground. 1 ground is over here. All are same. You can connect with any ground. Second one is a power. Power we have to connect with 5 volt. Power we are going to connect with the 5 volt in the Arduino. Using this 5 volt pin, you can give power to this sensor. That 5 volt power you can give to that sensor over there. Then after that, this one is a signal. signal wire you can connect with any digital pin like this. So I'm going to connect it with any digital pin. So I'm just going to connect it 4 number pin. Any digital pin you can connect it. These are digital pin 0 to 30. After doing connections, you can go to the code. In the code, there is no code. We have deleted previous one. So we have to go to the control first, take that forever loop, and then we have to go to if condition. Not if condition, directly we are going in input. Input means we want to read that sensor value on the digital pin. This pin number is which one pin we have used the sensor that we are going to use it. That is 4 number pin that we are going to use it. So I'm going to select over there 4 number pin. So whatever value we are reading it, we have to print it on the serial monitor. What is the meaning of that? Whatever value we are reading it, we have to check it out that what value is coming from the sensor that we have to display in somewhere in my computer. So for that we are going in the output and I'm going to take that print to serial monitor block, this one block. And over there I'm going to insert this one block in replacement of hello world like this. So that we have taken it and we can insert it like this. So now you can see whatever value we are reading it, we are printing it on the serial monitor. So start simulation and check it out. So in the sensor, you can do fit to screen over there. The sensor is over here and the value you can see in the serial monitor. This one is a serial monitor. So let me come back to that only graphical block so that you can see it more clearly. So now in the serial monitor, you can see sensor value that is 0 right now. As we are going to start simulation and we are going to, after starting simulation, we have to click on the sensor. As we are going to click it, it will show the range of the sensor like this. This one is a range of the sensor and this one is an object. Right now, the object is living being, but the object is stationary position. When the object is in the stationary position, so what is happening? The output will be 0. If the object is in the motion, you can see output on the serial monitor that is 1. One output we are getting it over there in the serial monitor. If the object is again in the stationary position, output will be 0. Mean we are getting logic in the format of 0 and 1. Binary logic we are receiving it over there. So what we have to do based on this binary logic, we are going to turn on and off any appliance. I'm just going to turn on and off any motor. So for that, we have to connect one motor with any other pin. So I'm going to take this motor that I'm going to make it on and off. So using this motor, you can open door easily. Door opening automatic, you can do it using this motor. So some mechanism you can make it for door opening using this motor. So that I have connected it like this. After doing connections, what next we have to do it over there? We are going in the coding. We have connected motor on the 12 number pin. Now we have to go over there and we have to make if and else condition. If the sensor value is 1, motor should be on, otherwise motor should be off. So go to the control. In a control, all the condition you are going to find it. So over there you can take if then else block, this one. So that we are going to take it. Now we are going to put if condition on the sensor value. So again you can take this block and put this one. But this one is not fitting over there. So for that one more block we have to take it. The block that we have to take it, that is math. In the math, there is a second block that is a comparison block. So this one we can insert it over there like this. So this one we have not fitted yet. This one block we have taken it. And now you can insert the sensor block over there like this. Sensor, we are reading sensor value on the pin number 4. And if the sensor value is equal to or less than equal to, now we have to take it only equal because sensor value we are getting it in the format of 0 and 1 in a binary logic. So now what next we have to do, if the sensor value is equal to 1, what we want to do, we want to turn on this motor. So go to the output and take the second block like earlier we have took for LEDs, and select pin number, that is 11 12 number pin for the motor, because motor is connected on the 12 number pin, positive, negative is on the ground. And in the else block, same block you have to take it, you can right click, duplicate, easily you can duplicate it and you can make it low. Mean motor will be high when the value is 1, otherwise motor will be low. You can check it out, is it working or not. And you can see on the serial monitor also value is 0, sensor value is 0, motor is off. And as we are going to click on the sensor over there, you can see if any object in a motion, what is happening, motor is turning on. You can see motor is rotating with some RPM. If there is no motion over there or no object in front of the sensor, what is happening over there, the motor will be get stop over there. Again, any person coming in front of the door, what is happening, the door is being get open, and if there is a no person over there in front of the door, door is being get closed over there, you can see it. So that is the concept that is behind in a smart door or automatic door over there. In that way you can make it. That is basic project that I shared with you. You can save it also, you can rename it, and you can save it. So whatever circuit we made it, that is being get saved. Whenever we are going to log in from any other location, any other, another computer using my account, so I will able to access my circuitry over there, and I will able to check it out, simulate it, and I can modify it also in the coding also and in the circuitry also. All these things we can do it over there. So this one is my project that is being get saved over there. So in that way, you can start working in the IoT application, start working in the circuit simulations. Sometimes we are not having hardware. You can start building basic circuitry, and you can move ahead slowly, and then after that you can connect with the cloud also. You can do condition monitoring of the machine also. All the advanced things also that you can do it. So over there we have just that's the very basic understanding of IoT, their applications. Now I'm moving ahead with the question answer. If any participant having any kind of doubt, queries, so feel free to ask over here. So these are my contact details over here. Further, if you want to know more detail, you can feel free to contact me.